Hello, my name is Kwan Yut Stephen Ho. I'm a data scientist from the Civic Health Group of Leidos. I will be presenting about my work supporting our federal client, and the title of this talk is NLP Applications for Scientific Review Assistance. And NLP stands for Natural Language Processing, as it is one of the hype words right now in the moment. And this work is done by me and a lot of my other colleagues in Leidos and also our federal client that I'm going to mention. The work that I am or we are going to cover here is for our NIH client. The IC, the institute and center called Center for Scientific Review, CSR. Leidos has been the prime contractor supporting CSR for more than 20 years. CSR mission is to ensure grant proposals to receive a fair, independent, and timely review from the scientific community, so it can fund the most promising research, most promising and impactful research. And NIH received about 88,000 grant applications annually, and 75% of them are reviewed by CSR. To do that, 250 or so scientific review officers in CSR must work with more than 18,000 reviewers each year and hosting about 1,300 review meetings. And each year, NIH received funding from the taxpayers of around 49 billion in 2023. So as you can see that the workload is pretty heavy. To reduce human bias and error and save time and money, it is imperative for them to speed up the process with machine learning and NLP. So here are some of the examples of the capability that we developed to support the review process. Our tools can be classified into three large categories. The first involve grant application with assisted referral tool and scientific similarity detection tool as examples. And today, I'm going to talk about these tools mainly, the assisted referral tool and science similarity detection tool in details. And the second category regards the review panel and emerging science with the project evaluating panel quality in review as an example. I will not talk about this in detail today, but we can be in touch if you want to know more about it. The third concerns the scientific community, where the reviewers are from. Some of the examples of the work include the sentiment analysis on the review narratives with our NLP tools, and also the reviewer network analysis. So first of all, let's talk about our first example, the assisted referral tool, or abbreviated as ART. ART is an NLP tool that recommends appropriate sections for reviewing a grant application based on the scientific content it carries. So by sections, I mean it's a scientific study sections. It is some sort. You can see it as a type of sciences that that the grant application is on. It may be bioinformatics. It may be immunology, maybe high performance computing, system biology, etc. So you can see the scientific study sections, something like this, subjects, fields, scientific areas, or biomedical science area that it is about, and the fundings are dispatched in terms of these. So it is very important that these applications to be in the right place, in the right bucket. Before CSR has art, they had to review grant application and classify each one of them into different scientific study sections. So it is a very mundane and largely manual process previously. It is very time consuming. However, after we developed art, the staff in CSR no longer need to review each study section to see if the document, the grant application matches it. They just need to put it to art, and it will give like a few of them for them to choose. They only need to review only 4% of the study sections. Because other sections are irrelevant. As you can see, 4% maybe are highly relevant. 5% may be relevant, and a lot of them can be ignored. And because art actually processed 9,400 grant applications monthly, it reduced 80% of the human labor. Art actually received a lot of compliments from the users, mostly from our clients. Compliments include something like art being easy to use, fast turnout for knowing the study section, that it is cool, etc. Yeah. So how does it work behind the scenes? So art works under the assumption that similar documents will be assigned to the same scientific studies sections. We can expect that it would be a right assumption for this tool. And for your information, there are actually two modes of art. One is like recommends directly the scientific study sections, and the other mode is suggesting it at a more parent group level. For example, like the bioinformatics or computational biology, but etc. And then maybe under a larger umbrella of biological computing, something like that. So so that's what the parent group are, and I will show you that in a bit. And also there's some animal study thing for art, which I'm not going to talk about today. So how does it work behind the scenes? It is actually a very typical natural language processing and machine learning process. First of all, it converts the user entered application's title, abstract, text about the grant applications, about their research, into an indexed form or an embeddings. The embeddings. And the embeddings are then input into an ensemble of support vector machines, SVM models. So that there are many support vector machine models behind, and the models will do inference on these embeddings for the grant applications. And afterwards, there will be a score calculated for each scientific study sections by voting on the result output from this ensemble. So actually, let's do a demo here. So let's come out here. So let me do a full screen. So here is the public website of CSR. Public.csr.nih.gov is public. If you want to use that, you can go here, use the assisted referral tool. Click here. Okay, and click here on the assisted referral tool. So here it comes with it. So for the demonstration purpose, we suggest using the first one, recommend study sections directly. The second one is pretty similar. Okay, so here we are actually in the tool that we developed. You can put the title and the text of your research here. For the time being, let me put sample here, then click on submit. So it will take some time to run. In behind, it is actually converting this text into embeddings and put into our machine learning models, and then a score will be calculated. Okay, so a result is comes out. As we can see that there are three scientific study sections that Art thinks it is relevant. You can even click on it to see what they are, to see if it is really a match or not, or click on this, etc. And this RB, the review branch, is what I previously called the parent group of the study sections. So it is the R2. It is public. However, for the CSR staff, they have another tool that enables them to run art in a batch, which is much less user friendly, but it is for the convenience to run this art for maybe 1,000 documents in a night. So they have their optimized tool, but this is public, and you can see how it is like. So that's art. So let's do the so let's go on to the next page. So we've done art. So the second tool that we want to talk about is a science similarity detection tool. So why doing this? It is known that some professors and grant applicants submitted duplicated grant applications to increase the chance for their research being funded. To avoid duplications and save taxpayers' money, because we don't want to submit the same thing twice, Division of Receipts and Referral, DRR, under CSR, has to review all the applications, all the grant application documents, and identify them and withdraw duplicated applications. Previously, it is a very mundane and manual process. CSR staff used to manually go through the applications submitted by the same PIs to identify and withdraw duplicated applications. This manual process is undoubtedly very time-consuming, and it is very vulnerable to error, and we don't want that. There are really a lot of documents. So every 2 months there are 18,000 such documents, and you have to review them and find duplications. It's very time consuming. So currently, we, Leidos, developed this tool. So instead of having the referral officers to review all the documents, our scientific similarity detection tool computed the similarities between all pairs of documents from the same PI. And then it will output. It is also a machine learning algorithm. It is an NLP based approach, and it will output a score between 0 and 1. And 0 meaning it's two documents are very similar, and 1 is they're very different. Yeah. So after that, then the referral officers only needs to review those pairs of documents that are deemed to be highly similar, and ignore the others because we know that they are totally not different at all. So by this, this reduced a lot of burden on the staff, and this made the mining of the similar applications, duplicated applications, more efficiently. It reduces the burden on CSR staff, eliminating efforts of manual checking. So it expands the scope of applications being checked for duplication as well. It also makes it efficient to identify similar applications quickly. So how does it work? Behind the scenes, it is an NLP algorithm. So we look at multiple applications submitted by the same PI, and then it is the abstract, the specific aims of each applications are converted into indexed form or the embeddings, and then converted and from this, there's a distance measured between all pairs of that applications from the same PI on the embeddings, and it will be calculated. So as I've said, if they're the same, the distance will be 0. If they're totally different, the distance will be 1. And we take out those that are highly similar, those that are very close to 0 for the subject matter expert to review, and some feedback will be given. So let's do a demo again. So here's the this is not really the UI that they have, but because they will receive this information from an email. But this is how I show you how it is worked. So suppose I have this brand applications document. Okay, so I just put it here for the time being. So and then I look through the grant applications submitted by this PI or some similar PI, and so on the back it is converting this text to an embedding, and then all the other text also to an embedding as well, and our distance will be calculated. Okay, here we go. So for example, this one, we know that this is highly similar to the first one. Okay, so the dispersion of volatile bacteria in a porous medium, and these are the text here, and the distance is 0.0117. It's very similar. The second one is kind of similar, and those at the back they're not so similar. Okay, so yeah, it is some of these are some of the examples that it is how does science similarity detection work. We'll put out this document and also these documents and then send it to the referral officer and the subject matter expert for them to review. Okay, so yeah, so here we've done the demo. So okay, so there are further enhancements to be considered. So now this similarity detection tool is being run regularly. It is weekly now, and it's being considered to be run daily. So to catch duplication as soon as possible, as early as possible, so that the similar documents will not be considered at a later stage. And this tool actually receives a lot of compliments from our clients. As you can see on the screen, it reduces bias and errors, it frees up the time, the mind, and the efforts, and of course taxpayers' money from this mundane task to something more complex and meaningful. So here's come to the end of my talk. If you have any questions, I'm happy to answer. Thank you.
As today's session comes to a close, I want to say thank you to all of our speakers and all of you for shedding light on the most recent breakthroughs in AI. I would like to thank each one of you for your engaging questions and for sharing your experiences. It's evident from our discussions that open source efforts play a pivotal role in applying NLP and LLM techniques in practice. The range of tools and models presented today tailored to tackle real-world business needs is truly inspiring. The accomplishments of the open source AI community in 2023 have definitely been impressive, and by all accounts, we are just getting started. We reconvene tomorrow at noon Eastern Time for day 2 of the NLP Summit 2023, with a spotlight on the role of NLP and LLMs in healthcare. We invite you to rejoin and be part of this ongoing discussion. Wishing you a pleasant evening and looking forward to our discussions tomorrow.